affine transforms are a way to transform pixels in a space, such as a plane, into other locations. And in this video, I'm going to demonstrate how to do that with Excel. And basically what you do is you have some sort of transformation matrix, and you matrix multiply it by the original vector to get the new vector back out. And this operation is achieved with the Excel function MMULT. So here's a picture of an arrow, which is just traced out on a scatter plot with lines in between the points. There's the original. Here's a quote-unquote identity transform, which keeps the original arrow. Translation just moves all the points to another place. Shear moves the points to another place, but bends the image around, as you can see here. Rotation spins the points around in the plane. And finally, we'll look at reflection, which just flips it around like a reflection in the mirror. So let's review some of the matrix math operations make this possible, and then jump back into Excel. So if you look up affine transforms on Wikipedia, you will find that there are two ways you can do this. One is with a matrix multiply plus a vector addition, the vector addition being for translation. Alternatively, you can put everything into a single matrix and single vector and just augment them with ones and zeros, as the case may be, and then just do everything with a single matrix multiply, which is what we're going to do here. So this is how we will augment the points. So normally you'd have an XY coordinate in a column vector like this. So basically, we'll just take the XY coordinate and then put a 1 underneath both of them, so it's a 3-element column vector. And of course, when plotting the points, we will remove the 1 and ignore it. So what I'm going to do is simply copy these values here over to our other spreadsheet, and then insert a scatter plot. I'll make it about as square as can be so it doesn't optically distort our transformations that we're doing. And then there's our arrow. And so the last thing I'm going to do is actually make the axes fixed. So I'm going to select axis, double click on it, go from -5 to +5, and then from -5 to +5 once again. And then doing that on each of our plots will help it make sure that we see the effects without rescaling the axes and distorting our arrow. So then I'm going to delete the grid lines, and there is our original arrow. So let's look at our first transform here. It'll be the identity transform. So what we need to do is set up a matrix to multiply our points by and perform the identity transform. So that is fairly straightforward. I'm going to go down here and type identity. And then the matrix, which will just be ones on the diagonal. So 1, 0, 0. 0, 1, 0, 0, 0, 1. And then I'm going to put a line of labels for our vectors we're going to transform. So X, Y, and augmentation. And so now here we go with how we're going to use MMULT. So it's going to be, let me scroll up so it's easier to see on the screen, equals MMULT. Then that matrix, I'm going to fix its reference so it does not move when I drag the formula. And then it's going to be multiplied by that. So we see that we are multiplying our vector, which is 3 elements high, by a 3x3 matrix to make the matrix math work. And when you do that, it spills down into the necessary cells to complete the operation. So if I just drag this across, it keeps all these vectors for each operation. So now I'll make another scatter plot to show the arrow, but I will speed up the video so you don't need to watch me go through every step like you already have before. And there is our identical arrow from the identity matrix. Now let's go look at our next transform, reflection. So that's almost identical to the identity matrix, except the first element here is a negative one instead of a positive one. So let's flip back over to Excel and take a look at how that works. Negative one, oops. Now with that set up, I will again work similarly to the identity matrix and make an MMULT formula. MMULT. Fix the reference with F4. Scroll back up to the original vector, the original first vector. Type enter, and then there's our first vector. And then drag it across to column M. And then insert a scatter plot. Fix the axes. Delete the grid lines. And there is our reflected arrow. So we can see how it points to the right with the identity transform and how it points to the left with the reflection. All right, so our next transform is going to be translation. So that's just going to move the points from one place to another. Let's take a look at how that works. So this still has all the ones on the diagonal, but for these two elements, we have Vx and Vy, which are the amount of translation in the X and Y axes, respectively, that we want to apply to every point. Okay, so let's flip back over to the spreadsheet and scroll down just a bit. And so I'm going to say, just as a hint, I'm going to color code this. So I'm just going to say 1, 0, 0, 0, 1, 0, 0, 0, 1. Just start with the identity here. Copy this. Make my matrix multiplications. Drag it across. And of course, this isn't going to change anything because it's the identity, but we'll be changing this matrix here in just a moment. But first, I'm going to put in the scatter plot. I'm going to fix the axes here as well so we can see what happens when we do a translation. Okay, so now what we can do is remember that this is the X translation, this is the Y, so I'm just going to put 1 here. And it moved it by 1 unit to the right there, and I'm going to put 2 here, and I'll move it 2 units up. So there is the translation matrix. I remember I promised color coding, and I should do that. So I'm going to make this like this color and then a lighter color where it can be modified. So our next transformation is going to be shear. And that looks like the identity matrix, but then we have CX and CY here in place of these zeros. So I will proceed as before and make an identity transform, which we will then modify to be a shear. Then I'll make my scatter plot. Select the data. Adjust the axes. Delete the grid lines. And now we are ready to modify these two elements. So let me color code this real quick. I'll make it this color. Make these this lighter color. And let's just do 1 here. Let's do -1 there. And so now let's look at rotation, our final operation we're going to do in this video. And this matrix looks a lot different. We have some cosine and sine functions here in these elements, and so these depend upon theta. So in the actual spreadsheet, I'm going to put a cell that you can enter in your theta, and then it will calculate the cos and sine of that value, and then dynamically change the chart. Okay, so let's type in some rotation here. And here will be a place to enter theta, which I'll initially set to 0 radians. Set up the translation or the rotation matrix like this. And then I'm going to color code this. And now let's perform the transformation. You know the drill. MMULT, fix the reference. Go up here, grab the first vector. Insert the scatter plot. Select the data. Adjust the axes. Delete the grid lines. And now for the fun part. Let's play with this. Now instead of 0 radians, let's do equal to pi divided by 2. Yay, it points up. Equals to pi. Yeah, it points left. Equals to 3 times pi divided by 2. And it points down. And then, of course, we could go back to 0 radians. So, what have we done? We have looked at a rotation transform, a shear transform, a translation, a reflection, an identity, all based on the original arrow. So I hope that you've had fun looking at these transformation matrices, and thanks for watching.